Every year, an impressive scene repeats itself across the world's oceans. Approximately 700 massive ships, including cargo vessels, oil tankers and container ships, remain anchored offshore, patiently waiting their turn to enter ports. This phenomenon, known as ship anchoring or offshore mooring, may seem like a simple logistical delay, but it actually represents a complex and strategic system that sustains global commerce and keeps the wheels of international trade turning smoothly. The primary reason behind this waiting is directly related to port congestion, one of the most pressing challenges facing modern maritime logistics. Today's ports operate near maximum capacity, functioning as true industrial hubs that process millions of containers annually. These facilities work around the clock, with cranes loading and unloading cargo, trucks moving containers to warehouses, and countless workers coordinating the intricate dance of global trade. However, when the number of arriving vessels exceeds the terminal's processing capacity, ships are forced to wait at sea, sometimes for days or even weeks. This scenario became especially common after major disruptions to global supply chains, particularly during the pandemic years when ports worldwide struggled to process containers quickly enough to meet skyrocketing demand. Lines of dozens of ships formed at major logistics centers like Los Angeles, Singapore, and Rotterdam, revealing the limitations of existing port infrastructure and highlighting the fragility of our interconnected global economy. Beyond operational bottlenecks, there's a component of deliberate economic strategy that many people don't realize exists. Many shipping companies intentionally slow down their vessels or keep them anchored to regulate the supply of goods and stabilize maritime freight prices. This practice, known as slow steaming, when vessels reduce speed, or strategic anchoring when they wait offshore, allows companies to control market dynamics. By carefully controlling how quickly cargo enters the market, these companies can avoid sudden drops in shipping rates that would hurt their profitability. When too many ships arrive at once and flood the market with capacity, freight rates can plummet, making voyages unprofitable. This practice, while controversial and sometimes criticized by economists and consumer advocates, is an economic reality of the global maritime transport market and represents a significant business decision that affects prices consumers ultimately pay for goods. Weather conditions represent another crucial factor in this equation that cannot be ignored. The ocean is an unpredictable and often dangerous environment, and safety must always come first. Storms, strong winds exceeding safe operational limits, heavy fog that reduces visibility to dangerous levels, or rough seas with waves several meters high can make docking operations extremely dangerous or even impossible. In these situations, ships receive instructions from port authorities and harbor masters to remain anchored until conditions improve, ensuring the safety of the crew, the vessel itself, and the port infrastructure that could be damaged by a ship attempting to dock in adverse conditions. Safety always takes priority over speed in maritime operations, and experienced captains know that attempting to dock during adverse conditions can result in catastrophic accidents, millions of dollars in damages to both the ship and port facilities, environmental disasters from cargo spills, and even tragic loss of life among crew members and port workers. Legal and administrative issues also contribute significantly to waiting times, adding another layer of complexity to the already intricate process of international shipping. Some ships remain offshore while customs inspections are conducted, with officials boarding the vessel to check cargo manifests, inspect containers for contraband or prohibited items, and verify that all documentation is in order. Documentation checks can be extensive, involving bills of lading, certificates of origin, health certificates for food products, and numerous other required papers. Port clearances must be obtained before a ship can enter, and this process can take considerable time, especially in ports with heavy bureaucratic procedures or in countries with strict import regulations. In other cases, vessels may be awaiting fuel replenishment, which requires coordination with bunkering ships that come out to meet them. They might be waiting for maintenance crews to address mechanical issues that arose during the voyage, or even for crew member changes, as maritime workers rotate on and off ships according to strict schedules governed by international maritime labor laws. These bureaucratic processes, while necessary for security, safety, and regulatory compliance, can add hours or even days to total waiting time, frustrating shipping companies and their customers who are eager for their cargo to arrive. Contemporary environmental regulations also play an increasingly important role in modern shipping operations. Several ports around the world have established strict limits on the number of ships allowed simultaneously in their internal waters, implementing what are known as emission control areas. These regulations aim to reduce air pollution from ship exhausts, manage greenhouse gas emissions that contribute to climate change, and protect fragile marine ecosystems from the various impacts of heavy shipping traffic. Ships produce significant emissions from their diesel engines, and concentrations of vessels in port areas can create serious air quality problems for nearby communities. Keeping ships anchored offshore, where their emissions disperse more readily, helps ports comply with increasingly demanding environmental standards set by international organizations and national governments. This represents an effort to balance the demands of global trade with ecological responsibility and the health of coastal communities. Some ports also limit traffic to protect underwater habitats, reduce underwater noise pollution that affects marine mammals, and prevent oil spills in sensitive areas. From a technical perspective, anchoring these gigantic vessels is a complex and fascinating engineering operation that showcases human ingenuity. Ships deploy massive anchors, some weighing several tons each and standing taller than a person, connected to heavy chains specifically designed to hold thousands of tons of ship in place. These chains, each link weighing hundreds of pounds, extend deep into the water and must be strong enough to withstand enormous forces. The anchors themselves are engineered to dig into the seabed, whether it's mud, sand, or rock, and hold firm even against powerful ocean currents that can push with tremendous force and intense winds that create significant lateral pressure on the ship's hull and superstructure. Despite their colossal size, some container ships are longer than 4 football fields and taller than 20-story buildings. Modern ships can remain surprisingly stable while anchored, thanks to advanced stabilization systems, carefully calculated anchor placement, and the fundamental physics of how these massive anchors interact with the seabed. However, prolonged anchoring is not without significant challenges and costs that shipping companies must carefully consider. Extended waiting increases fuel consumption needed to keep onboard systems running, including generators for electricity, climate control systems for crew quarters, refrigeration for perishable cargo, and navigation equipment that must remain operational. This raises operating costs substantially, sometimes by thousands of dollars per day.